Good morning. Today what we're going to do is start into Pre-Calc 20, Chapter 2. We're going to talk about angles in standard position today. When we talk about an angle in standard position, there's some guidelines that go along with an angle that is in standard position. They talk about the initial arm of that angle being along the x-axis, the positive x-axis. The terminal arm of that angle is a movement from starting at the initial arm, going counterclockwise, and ending in one of the four quadrants. And so for our focus today, our angles are going to be moving counterclockwise. It is possible to talk about an angle that moves clockwise, but for our purposes, any angle that moves counterclockwise is going to be considered a positive angle. And when you see it move, if it ends in the first quadrant up here, we're talking about an angle between 0 and 90 degrees. If it ends in the second quadrant, it's going to be between 90 and 180 degrees, and so on. So the example that you see here measures an angle, a positive angle. So we would say angle theta could be approximately somewhere between 90 and 180. I'm estimating maybe, 130 degree angle, perhaps. So we're going to focus on talking about the standard position angles. We're going to be talking about the quadrants that they fall into and the things that we're going to be measuring with these standard position angles. So one thing that we're going to need to be able to do is to, with some accuracy, measure this angle in standard position. This is asking us to sketch the angle, so it's not necessarily going to be 100% perfect. You may need to take out a protractor and measure it to be certain. But essentially what we're asked to do is, in this example, to measure a 36-degree angle. So for an angle to be standard position, the vertex at the origin, the initial arm on the positive x-axis, and 36 degrees would be maybe approximately here. And so we use arrowheads to show the direction to make sure we are moving counterclockwise so that we are talking about this 36-degree angle. It's asking us to state what quadrant it lies in. This is quadrant 1. And so therefore, quadrant 1 angle of 36 degrees. If we were to talk 315 degrees, again, when we draw a standard position angle, the vertex is at the origin. The initial arm is on the positive x-axis. And if we're going to go 315 degrees, often what I do is I count. I know to here is 90, then to 180, then to 270, and so I need another about 45 degrees, which would be halfway through, to get a 315 degree angle. There's my arrow showing direction so that I have a 315 degree angle, and it's ending down here. So when we count our quadrants, it might be important for you to remember quadrant 1, 2, 3, and 4. Those quadrants are numbered counterclockwise as well. And what we have is a quadrant 4 angle. So quadrant 1 was our 36 degree angle, and quadrant 4 for our 315 degree angle. So drawing angles with some accuracy in that standard position is to begin with. We're also going to be referring to what's called a reference angle with these standard position angles. And when we're talking about a reference angle, it's an acute angle, vertex is at the origin, but what we're focusing on is where the terminal side of an angle stopped and the closest x-axis. So we are talking about, in this example, a 230 degree angle that ends down here in quadrant 3. But the measurement of the angle between that terminal arm and the closest x-axis ends up being a 50 degree angle. So that's why we would say the reference angle for a 230 degree standard position angle is a 50 degree reference angle. So here is some guidelines as to how to keep track of what that reference angle is. The red angle that's marked off is our standard position angle, And from that terminal side to the closest x-axis, and I often will do this just to kind of draw in my reference angle, would be the measurement between the terminal side and the closest x-axis, which in this case is the same as the original angle. If we're talking about a quadrant 2 angle, it has a terminal side here. The closest x-axis is here. So here is where we would see our reference angle. And again, there's a quick little rule as to how I would remember how to find the measurement of that reference angle. But I think that if we were to say that this original angle was 140 degrees, we have to remember between 140 degrees and the closest x-axis would be 180 degrees. What would be the distance between those two? And so we would be able to say that in this particular case, little r for reference angle would be 40 degrees. If you are talking about a third quadrant angle, as we saw in the example, again, between the terminal side and the closest x-axis, we're talking about here is where we would see our reference angle. If we had a standard position angle and in quadrant 4, the closest x-axis is here, and again, we are talking about the measurement between that terminal arm and the closest x-axis, how many degrees are in that spacing. So part of our discussion today will be reference angles. So for example, they want us to determine the reference angle for each angle that's here. We're going to draw the original angle in standard position, and then we'll label the reference angle. So back to our axes. Drawing that standard position 130 degree angle. Again, the vertex is at the origin, the initial side along the positive x-axis. And if I'm going to go 90 degrees, I need another 40 degrees, which may end up about here. And that is going to be my original standard position angle of 130 degrees. My reference angle is going to be between there and the closest x-axis. And I tend to draw it like this, I guess kind of like a spider web if you want. Between there, the reference angle between 130 where the standard position angle stopped and 180 degrees would be an extra 50 degrees. A 300 degree angle is going to end in quadrant 4, and again, vertex starting on the positive x-axis, going around 90, 180, 270. We need another 30 degrees, which would end up approximately here, to get to our original angle of 300 degrees. And then our reference angle is going to go between that terminal side and the closest x-axis, which would be here. So my reference angle would be the number of degrees I need to go from 300 back to 360, one full circle. And so we're talking about an extra 60 degrees. So while there are little formulas to remember how to find the reference angle, what calculation that you need to do, I think that we need to understand some basic numbers. It should be something that we don't need to remember a bunch of small formulas for. So reference angles, determining the reference angles. And a last question here, just to get a little bit of practice with some of these standard position angles. It says determine the angle in standard position when an angle of 60 degrees is reflected. So what they are talking about to begin with is a 60 degree angle, and I'll just get that drawn. Standard position, vertex at the origin, initial side along the x-axis, and if we're moving in that positive direction, there is our 60 degree angle. Okay? Now what they're saying in part A is that we're going to take that angle and reflect it in the y-axis. If we're talking about this being the y-axis, this angle is going to flip over and it's going to be mirrored on this side approximately. And they want to know what the standard positional angle is going to be. So for part A, if we were to talk about the angle stopping here, Now we're talking about an angle that is 60 degrees. Now, the reference angle is going to be helpful here. If we have a reference angle of 60 degrees here, we're going to have a 60-degree reference angle over here. So we would just keep track that we are talking about a reference angle of 60 degrees. So then what is this angle going to be if it's 60 degrees away from the closest x-axis? Doing a little bit of the math in our head, we know that we're going to have a 120-degree angle. What if we were reflecting it in the x-axis? So this is part A. Part B. If we, again, start with that 60-degree angle in standard position, initial side along the x-axis, there is our 60-degree angle. So I'm just rewriting that. But now what we're talking about is reflecting it in the x-axis. So if I were to reflect this over the x-axis, we would be having a mirror image down here. So the question is saying, what if we are talking about now a standard position angle that is going to be reflected in the x-axis? Again, that reference angle would be helpful. Whatever angle you have here is going to be identical to what we have down here. So in part B, we're asked to figure out what this new angle, this new standard positional angle is going to be. If we understand that we again have a 60-degree reference angle, so that means that I've gone all the way around but not finished a circle by 60 degrees. So I haven't gone 360 degrees, 60 degrees short. I'm talking about a 300-degree angle. So it's using the reference angle to do this type of an example. That's really what we're going to do to begin with for the first part of this section 2.1 of Pre-Calc 20. That's all. Have a good day.